$5 billion. I just want you to let the sheer gravity of that number sink in for a second, right? In the tech world, that's not just a funding round. That is literally the GDP of a small nation. It represents an astronomical investment, a bottomless war chest, and the staggering financial scale of what is arguably one of the most highly publicized and ultimately disappointing tech ventures in modern history. We hear constantly about the limitless, almost magical potential of artificial intelligence. I mean, we're told daily how it's going to revolutionize absolutely every aspect of our lives overnight. But what happens when the ambition is sky high, the marketing budget is virtually infinite, and the actual underlying technology just hits a brick wall? Well, you get a $5 billion wake-up call.
Today, in this explainer, we're unpacking a truly cinematic story of tech ambition, the Watson Waterloo. Our central theme here is the incredibly dangerous and honestly sometimes blinding gap between brilliant marketing hype and cold, hard technical reality. We're going to dive deep into the rise and fall of IBM Watson Health, the audacious moonshot that completely missed its orbit, and the absolutely crucial, enduring lessons it leaves behind for the entire future of artificial intelligence.
To understand the crash, we first have to understand the launch. Part 1. The Jeopardy high and the birth of the AI hype cycle. I want you to cast your mind all the way back to 2011. Millions of people were glued to their television screens, watching in absolute stunned silence as an IBM computer named Watson utterly demolished Ken Jennings and Brad Rutter, the two greatest human champions in the history of Jeopardy. It was this breathtaking, watershed moment for technology. The public amazement in the immediate aftermath was just absolute. We just watched a glowing metallic avatar on a screen perfectly understand nuanced human language, tricky puns, and complex riddles in real time. And because that visual was so powerful, so incredibly persuasive, the hype didn't just grow, it went completely stratospheric. The collective assumption of the public, and frankly the tech industry alike, was pretty simple. If a computer can beat the smartest humans on Earth at trivia, well, surely it can do anything, right?
That unchecked optimism fueled a massive leap. Part 2, the medical moonshot, from trivia to treatment. So the decision was made that this triumphant machine wasn't going to just answer trivia questions anymore, it was going to literally cure cancer. But here's the thing, Jeopardy is essentially a closed ecosystem. The answers are entirely factual, completely objective, and neatly categorized in digital encyclopedias and databases. Human biology, on the other hand, not a trivia game. It's chaotic, it is highly unstructured, and the fundamental rules of disease are constantly changing and mutating. Transitioning a machine from a neat, tidy world of absolute facts into the unpredictable and entirely messy reality of human biology is not just a pivot, it's a leap across a massive, potentially uncrossable chasm. Which brings us face to face with the reality check. Part 3, the data problem. This is the technical hurdle that brought this soaring ambition crashing right back down to earth.
In the world of computer science, there's this ancient golden rule you've probably heard. Garbage in, garbage out. An algorithm, no matter how sophisticated, no matter how many Jeopardy trophies it has sitting on its mantle, is only as good as the information it's fed. Machine learning relies on pristine, structured information to identify patterns and make predictions. Teaching Watson medicine was fundamentally harder than teaching it trivia, because the data in the medical field wasn't just unclear, it was a sprawling, disjointed labyrinth. And to a machine craving order, the information it was being fed was frankly a nightmare. Just think about your last trip to the doctor and the sheer cacophony of information generated. Your patient history is often just a massive block of unorganized text. Your medical records are messy, they're fragmented, and they're usually trapped in siloed databases across totally different clinics. The clinical notes from your visit might contain a hurried, handwritten scrawl, a scanned PDF of a lab result from 3 years ago, some weird abbreviation that only your specific physician uses, and a completely subjective description of how you're feeling on a scale of 1 to 10. Now, human doctors navigate this messy, contradictory context naturally through experience and intuition. But to an artificial intelligence trying to meticulously calculate an absolute, definitive cancer treatment path, this unstructured, chaotic data was completely paralyzing. It simply could not process the chaos of a living hospital the way it processed tidy encyclopedia entries for Jeopardy.
But of course, the public didn't know about the data problem. So we enter Part 4, the marketing gap, the incredibly dangerous disconnect between hype and reality.
The public perception, which by the way was heavily fueled by these brilliant, deeply cinematic television commercials featuring Watson casually chatting with celebrities like Bob Dylan, was that Watson was a singular, all-knowing artificial brain capable of solving the world's most complex medical mysteries. We all pictured this glowing, unified entity sitting in a sleek, dimly lit room, thinking deep thoughts and spinning out miraculous cures for humanity's worst diseases. I mean, it was an incredibly compelling narrative. It was the future we had been promised by science fiction for decades. Who wouldn't want to buy into that? But backstage, the reality was starkly, brutally different. Watson Health was not a singular, all-knowing brain. It was a chaotic patchwork of disconnected software and wildly disjointed tools. To try and quickly build this medical titan to match those massive marketing promises, the company had gone on a crazy billion-dollar spending spree, making pieced-together acquisitions of various healthcare data companies. So you have these frantic engineers working with basically digital duct tape. They were tasked with forcing entirely different code bases and systems to talk to each other, all while simultaneously trying to feed them that overwhelmingly messy, unstructured medical data we just talked about. The marketing department was out there selling sleek, unified magic, while the engineering department was drowning in a fragmented reality. And when the gap between what you promise and what you possess gets that wide, the structure eventually collapses. Part 5. The fire sale. The inevitable crash. The collapse happened in a devastating, sequential arc. First came the overpromising. Marketing set an impossible, almost mythical standard, literally curing cancer, that the underlying technology simply wasn't ready to meet. Then came the harsh underdelivery. When deployed into actual living hospitals, Watson deeply struggled to provide useful insights. The real-world medical data was just way too chaotic for its algorithms. So instead of saving time and saving lives, doctors became deeply frustrated, reporting that the system was creating confusion and recommending questionable treatments. Which led to the sad, inevitable conclusion. A magnificent $5 billion moonshot, the highly touted Watson Health division, was unceremoniously dismantled and sold off to a private equity firm for a mere fraction of its original investment cost. The grand experiment had officially ended in a fire sale. The entire endeavor leaves us with a fascinating and honestly sobering look at the gap between marketing hype and technical reality. And you have to understand, this isn't just a story about one company's misstep. It is a profound cautionary tale for the entire modern tech industry. Artificial intelligence is an undeniably powerful tool with vast world-changing potential. But when we allow the marketing department to drastically outpace the engineering department, when we promise absolute miracles without respecting the massive, gritty hurdles of real-world application, like, cleaning up messy human data, we don't get innovation. We get remarkably expensive disappointment. AI needs healthy, rigorous skepticism just as much as it needs venture capital funding. So I want to leave you with this final provocative thought. Could the machine that conquered Jeopardy ever really cure cancer? Or will the inherent chaos of human biology always defy the neat, tidy algorithms of Silicon Valley? The Watson Waterloo proved unequivocally that intelligence in a controlled game is entirely different from intelligence in the messy real world. The next generation of developers really must learn from this multi-billion-dollar stumble and focus not just on building a smarter machine, but on truly, deeply understanding the beautiful, chaotic, human reality that machine is trying to operate